Okay, in this video, we're going to discuss circuit schematics and the two major standards used to represent circuits. We've already seen a number of these symbols in previous videos, although I haven't really gone into too much detail on them, especially when we do work on circuit simulators such as EveryCircuit and Falstad. However, in this video, we're going to get into a bit more depth, although a video that would review all the symbols, even in a single standard, could take hours. So what is a schematic exactly? Well, a schema is any structured plan, framework, blueprint, whatever, that's a visual representation of something. In our case, it's going to be a circuit, and actually it could be something as simple as just thought bubbles when you're trying to start to organize your plan for a circuit. A schematic is essentially the same thing, but used in a different context. When we discuss schematics in our context, usually we're going to be talking about electrical schematics or circuit schematics, and they're usually drawn to a very specific standard. A schematic allows us to organize and represent something in such a way that it's both readable and understandable to a third party through the use of that shared standard. Of course, I keep mentioning standard, but if the schematic is to be universally understood, it needs to abide by some kind of agreed upon standard of symbol representation. This breaks barriers such as experience, language, context, etc. An American engineer who speaks nothing but English and a Japanese engineering student who speaks nothing but Japanese can both understand an electrical schematic if they're familiar with the standard used. Obviously, there's going to be some cases where descriptor text has to be translated, but the basic layout of the circuit should be understood. All right, so what schematic standards are actually out there? Well, first is IEEE, also known as ANSI, and often referred to as the American standard. This is what you'll encounter by default in most of my videos, circuit simulators, textbooks, etc. It focuses a bit more on using pictures for symbols, but it's not extremely different from other standards such as IEC. IEC is sometimes called the European standard. It's actually probably the most used across the world outside the United States. It focuses on a bit of a cleaner and more minimalist design when possible. Although, again, the standard isn't so different from IEEE that you can't figure out one from the other. Then there's JIS, which is Japanese Industry Standard. You probably won't see this much outside of Japanese electronics, and even then, there's a lot of Japanese electronic schematics that use IEEE or IEC, again, depending on the audience. If you deal with a lot of Japanese electronics, hobbyists, your student, whatever, you'll probably encounter it, but outside of that, I don't think so. There were some old German standards, DIN and VDE. They predated and influenced IEC. You might see these in some legacy German documents, but we're talking pre-unification. I think by the very late 80s, maybe yeah, going into the 90s, they had already switched. Then there's NFPA or NEC. It's some kind of standard used for fire protection with safety and wires, and electronics, and whatnot. I've never seen it outside of any of that, so I don't think it's used for anything else. And then we have BS, which again I kind of find hilarious. It just means British standards, and it was what the British used prior to IEC. Again, some similarities to DIN and VDE is in the sense that you'll only encounter these in old British schematics. All right, here we have an example circuit in IEEE. You should be able to recognize most of these symbols from our previous video. You'll notice ground symbols, there's a lot of those. Inductors, measuring the values here, nanohenries and whatnot. You got a bunch of resistors, those show values in ohms. You've got both regular capacitors and then you've got variable capacitors. We haven't really looked at the variable capacitor symbol much yet. You've got nodes, those are little dots, including the ones that apparently have a circle around them. You've got wires, and then also you have value labels too. There are literally hundreds of symbols in the standard, but to be honest, most engineers only memorize a few dozen and just look up the others. So don't worry about actually memorizing, 100 of them or anything. Like for example, there's a bunch of symbols for vacuum tube components, and you probably won't encounter those much unless you're working with vacuum tube amplifiers. All right, we're looking at a schematic from EveryCircuit here using the IEEE standard. And we also have The same schematic shown in Falstad. We can see the values, we can see the components. We got what, four resistors here, two capacitors, and two transistors, which we haven't covered yet. But if you, and of course the one in every circuit also has LEDs for demonstration purposes. But yeah, it's basically the same circuit, so you could use the schematic to recreate something in real life. The only thing that would be really important would be which B and T transistors um, you pick. But other than that, yeah, you might want to consult data sheets, real life models, and all that kind of thing. But again, you've got a schematic laid out. You could recreate this into a real life circuit, and somebody who's not you, doesn't speak your same language, same experience, could also do the same. Now, if you're curious about IEEE here, I've brought up a page that has supposed to have all the symbols or most of them. I think there's even symbols in some kind of errata and updated symbols, but this should cover most of everything. And then this, it says reaffirmed 1993, 1988. So actually the symbols probably date back from 1975 without any real changes. Um, Going through here, we have qualifying symbols, which are extra symbols next to the main symbol. Graphic symbols for fundamental items. Let's see, transmission path, contact switches, connectors, relays. Let's see, terminals and connectors, transformers, inductors, windings, electron tubes, yeah, related devices, semiconductors, circuit protectors, acoustic devices, and the list just keeps going on and on and on. And I guarantee you there's nobody who recognizes all of these, not even a fraction. Let's see. So anyways, yeah, here's a quick reference to various symbols. So these are qualifiers in the first one. So, if it says variability, adjustability, you'll see one of these symbols on top of or next to, say, a capacitor. Um, and then connections. I have no idea where there's a little Star of David symbol on connection symbol. I've yet to figure that one out. Um, it's possible some of these are almost never used. And maybe they added new ones for newer technologies. I don't know. I'm still looking into that. But yeah, you got capacitor symbols, um, the resistors, and actually it even includes something similar in the middle here to IEC, and I have no idea about this third symbol, although I think I've seen it before. But yeah, I just go through here and I just look at different things. Battery symbol, that's pretty simple. Spark gaps, transmission paths. We keep going. Circuit return, so this is where we're seeing some grounds. And this one that sorted me looks like a little bit of a pitchfork. I think that's either chassis ground or earth ground, I can't remember. Electrical contacts. Yeah, it's just said a lot of stuff. You got switch symbols right here. Although we've obviously seen some variations because symbols have been probably modified considerably since 1975 in a lot of ways, especially at certain circuit simulators. Um, and push button momentary switches. Let's see, just switches, switches, switches all the day long. Um, Thermostat. There's actually symbols for telegraph key, believe it or not, right here. Because it had to cover, I think, just about anything you could possibly run to, and it is possible to have a telegraph machines with the little button and stuff still exist. It can be used with ham radio and a lot of other stuff. Let's see, relays, terminals, yeah, telephone, induction repeating coils, because obviously, telephone circuits and all that. Electron tube stuff. Let's see, what we got. Semiconductors. Oh yeah, nuclear radiation detector. There we go. We got a symbol for that right here. Um, you'd probably see this with a Geiger counter. Let's see what else we got. Photosensitive cells, thermocomps, fuses. Um, I've made the mistake of mistaking fuse symbol for the IEC resistor symbol before. I didn't say I'm a smart person. Let's see, circuit breakers, relays, acoustic stuff. Let's see, rotating machinery. Obviously, this has to make circuits for industrial purposes. What else do we got? Again, I don't recognize half of these. Then again, I'm still sort of entry level. Amplifier. Let's see, filters, phase shifters. Balloon, we mentioned that in, I think, Introduction to Passive Components. Magnetron. Let's see what else. Rectifier. Yeah. Let's see. Go in here. Summing amplifier. We're going to get into op amps in a future video. There's actually space station symbols. Yeah. Go ahead, huh? And there we go. We're done. But yeah, there's a ton of pages to this. I don't know how long it actually is, but let's see. Oh, 244 pages. So this is a book. Actually, it might include some information. Oh, also with IEC stuff too, because there's cross references. The two standards are meant to sort of be able to work together. Um, or if you don't know the symbol in one and symbol in the other, but the actual differences between IEEE and IEC are a lot less than people think. And I guess these are deleted symbols and everything. But anyways, that's just to give you an idea there. All right, I'm going to take a sidetrack here into EveryCircuit. Now, there's not a whole ton of components on EveryCircuit, so that they keep it simple. But I have it. I think I have it set correctly to see. Yeah, okay. So it's going to be IEEE simple. So like you got DC source, you got current source, you got AC source, and then of course you just got the one kind of ground. So this is all about keeping it simple. You have your resistor, your potentiometer. For some reason you have, well, I guess a lamp. You can use that with AC. We'll get into that later. Got a DC motor. Got your reactive, so your two capacitor symbols, and they're using the curved one for polarized capacitor, whereas with, I believe with IEC, this would still just be two straight lines. You got your inductors. This is a transformer, and this is a symbol. Again, future videos. You got switch symbols, which I think all pretty much conform. Got a very basic op amp symbol here. You got some controlled sources symbols. I'm not sure how much these match up to IEEE. You got some diodes, not a whole ton. And for some reason, the 7-segment display is under diode. But again, we'll get into that later. You got two basic sets of transistors. You just got B and T's, and you've got basic MOSFET symbols and some logic source stuff, some logic gates, latches. Again, I'm not certain things. I'm not entirely sure how close it is to the proper IEEE symbols, but yeah, you got the idea. Now, I think now if I change it to IE, let's see what that actually changes. Not much. I think the only thing on every circuit that changes is just the resistors. I don't see any other changes off the top of my head. So we'll just switch that back. All right, well, this should give you an idea for every circuit. Now moving on to IEC, here's a chart of symbols, which again are pretty similar to IEEE. Would say the biggest difference between those is the symbols used for resistors. With IEEE, it was a squiggly line, and with IEC, it's a thin rectangular line. The value could be written near that rectangle or actually inside it in some cases. Although there's a lot of preference to this because you can't screw up a small rectangular box as much as you can a squiggly line. That's the one complaint with IEEE. If you don't draw something correctly, it could look like a resistor or an inductor, and you don't have quite that problem with IEC. Now here's just a quick 5-5 timer circuit done in IEC. You'll notice the differences um, with, yeah, also with the polarized capacitor. But this is still close enough that if you're not familiar with IEC, you could probably figure it out with knowledge from IEEE. Here is the same circuit from EveryCircuit, but in IEC. The only real difference here is just the resistors. Same circuit in Falstad, but again, IEC gates, so that you see the change in the resistors. All right, I think this shows schematic symbols for IEC. So I mean, it's all of them. Goes on and see if I find anything. Some of these are qualifying symbols. Let's see. Let's put in resistor and see if we, yeah, resistor general symbol, adjustable. That the arrow there is a qualifier. And then capacitor down here, general symbol, polarized, yeah, a plus. So you're not doing the kind of the weird twisty bendy parts to a capacitor with IEEE. Try to keep some of the symbols a little simpler. But again, people have to be able to sort of know, not too different, or else it'd be confusing. So diode, semiconductor diode, a general symbol. Um, there's a LED right here. Temperature, variable capacitor, diode, varactor. Mentioned tunnel diodes and a few other things. But yeah, there's pretty much, I'm sure, a symbol for just about everything. And I only understand a fraction of all of this. Well, that should give you an idea in terms of the schematic symbols. Now let's take a look at Falstad, and there's a lot more symbols in Falstad. I mean, passive components, switches, transformers, transmission lines, uh, relay coils, thyristors, photoresistors. Sure how you simulate with this, unless it's just oh, I guess it's just a light brightness thing. Okay. And I think for this, it says IEC gates. I'm not sure the difference there, but just turn that off. Yeah, you got a lot more things you could put down. And again, I'm not sure which ones are standard to a standard or it's just Falstad. I mean, you got things for text boxes, lines, etc. So you can do a lot of labeling, which you can't do in every circuit, as far as I know. Decimal display. Let's see, what does that actually show? Okay. And again, some of these things are extremely generalized. They're not to a specific chip or item or whatever, but you can use subcircuits for that. Now, one thing to note with schematics, when they show chips, it's not going to necessarily match the physical layout. Um, if this was double inline pin with pins on either side, you'd be limited to those sides, but it's not. So you can put your nodes basically anywhere you want around in whatever order you want.